Hey guys, so if you haven't already noticed, I'm obviously not here today. I'm not sick, I'm not quarantining, just to clarify so nothing like that happens. But this is going to be good practice if that ever does happen, but just know that that's not the reason. So, in order for this to work and this to not be a wasted day, um, while you're doing these lessons and you're watching, you need to be taking notes just like as if I were in class, okay? Because I'm doing these at home, and so I want you to still get something out of it. We can ask questions when I get back. So, if you're confused, don't panic. I'm going to do my best to explain this as well as I would if I were in class, but I'm going to need you to take notes as if I were there. And then any questions you may have throughout, maybe pause the video and write them on the side, so that when I come back and I see y'all again Friday, then it will be like we didn't even skip a beat. Okay, because you'll probably still have questions. I may forget to do something because I'm not right there with you to answer. So if at any point during this I tell you to pause the video and think and answer it and then come back, please pause the video and do that, because it's not going to help you if you just go through it and just write everything down, but you're not actually thinking about it. Okay. Um, but other than that, that's what we're going to be doing. So we'll just get started right into it. So this is lesson 2. Um, some of you may be able to skip ahead from where we left off in class, um, but this will just be a recap. So if you feel like you need a recap, just keep watching. If not, then you can skip ahead to wherever we were in class. But this is 2.1. I notice and wonder. Um, so our goals for this lesson, this entire lesson 2, is understanding box plots, dot plots, and histogram, and then understanding the 5-number summary. So the first thing we're going to do is a notice and wonder. This says the dot plot, histogram, and box plot summarize the hours of battery life for 26 cell phones constantly streaming video. What do you notice? What do you wonder? Okay, so on one side, you're going to do a notice, and on the other side, you're going to do a wonder. All right, these are my favorite things that we do in this class just because I feel like it gives you an opportunity to really examine it. So I want you to take a second, maybe a minute or two, look at your clock on your computer, a minute or two, and try to come up with one thing you notice and one thing you wonder. And when you're doing it, make sure that your notice and your wonder are mathematical. Don't say, I notice that it's blue or whatever like that, or that it's about battery life. So we already know all those things. But just try to come up with something. So pause the video. I'm trusting you to do it. And then come back. Okay, so a couple of things I notice when I'm looking through this is um, when I'm doing this, when I'm looking at this dot plot up here, I notice that there are a lot of cell phones in this category. Okay, so according to this graph, the majority of the cell phones, the battery life lasted majority of battery life lasted about 5.5 hours. Okay, that's one thing I noticed. I also noticed that down here, that's not a very long time for a phone to last. 2.5 to 3 hours, that's not very long. I also noticed that each graph is showing the same data, which is weird that they're all the same data because each one of my graphs looks different. Okay, so it's weird that this one's talking about all the different same battery lives, the 26 cell phones constantly streaming video, as this one, because I see it has the same range. It goes from about like 2 to 7, and it kind of has similar ups and downs, but it's not exactly the same. So I wonder maybe why it's like that. Okay, so maybe If it's the same data, why do they look different maybe? Okay. And again, if you don't get one of these, just pause the video whenever you need to and get those copied down. All right, what else do I notice? Well, one thing is when I'm looking up here at this dot plot, which is what this is, and if you didn't know that, you can label it. This is a dot plot. Okay, and I can see that because it has dots on it. Is that when I'm looking at it, I can see that there are phones that have 2.5, 3, 3.5, 4. But when I go right here to my histogram, which is what this is, so you need to label it. When I go here, I see that I can't tell if it's 2.5 or 2 or 3 or 3.5 or 4 or 4.5. Okay, because histograms actually group data into intervals. Okay, so that's something important to know, and we're gonna talk about as we move forward. All right, and then this last graph right here is a box plot. So as far as my other classes have told me, this is not something that y'all have talked about before. So that is going to be something we kind of expand on. So maybe something you wondered was, what is this graph? What is it showing? Or how do you read it, or what is it? Okay. So yeah, also just a couple little last things when we're talking about these is, and we're going to continue talking about, is when we're looking at all of these different graphs that we're going to continue to look at throughout this unit, is that when you're looking at different types of graphs, whether it be a box plot, a dot plot, or a histogram, each one of them is important or beneficial for different reasons. So with the dot plot, it's really easy to see some of the exact data. I can tell that there's 26 people that they researched. I can tell which ones were at 2.5, which ones are at 3, which ones were at 3.5. So it gives me very precise information. But with dot plots, it's not really beneficial for large sets of data. So if we would have interviewed 1,000 people for this question, for their battery life, it would have been very hard to read a dot plot with 1,000 little dots on it, okay? So it's really good and specific for smaller sets of data, but when we get to larger groups of data, we wanna go to something like the histogram, which is this, which looks very similar to a bar graph, except that each one of its little boxes are connected, okay? So that's what makes this different than a bar graph, is that all of those little towers are connected. All right, and also, like I was saying, for using this for large groups of data, the x-axis is actually sorting the numbers into intervals. Okay, so from 2 to 3, it's showing how many cell phones lasted at 2 hours and 2.5 hours, but it doesn't include the cell phones that lasted 3. Okay, that's where the next box starts. So it goes 3 to 3.5 and doesn't include 4. The next box starts 4 and goes to 4.5 and continues. But larger histograms can be from like 0 to 10, and then 10 to 20, and then 20 to 30, and so on. So histograms are better for larger groups of data. Now, a box plot is something that y'all have never looked at before, but when we're looking at box plots, it tells us the 5-number summary. Okay, and if you remember back to our goals that we wrote at the top of our paper here at the beginning, that was one of our goals, the 5-number summary. So we're going to kind of explore that more as we move forward, and what all that means. So yeah, so that is 2.1. So moving on, we're going to go to 2.2. And we're going to talk about how to use our calculators to take this these like large groups of data and kind of organize them into a graph, so that eventually we can take those graphs and we can interpret them and analyze them, kind of like we talked about that people do with statistics. Okay, so we're going to be looking at all this data right here. So we're going to be talking about tomato plants, and more specifically how to organize it into a histogram. So at this point you need to have your calculator. So whether you have your own personal calculator or the app, now is the time to get that. Okay, I'm down here now because I had to get my calculator pulled up. Okay, so at first this is going to look like a lot of steps, but just like what we learned with fractions and everything else that we did, we're going to learn something else that these calculators can do that's going to make your life so much easier than doing it like by hand. Okay, so before we get into all of that, we're going to see what this data is talking about. So going back, trust this real quick. Okay, there we go. So this may be really good for you to split your screen with your calculator and your video that you're watching, okay? Because you're gonna want to be able to watch me explain it and showing you how to use the calculator and also practicing it with me as if I were in class, okay? So maybe pause the video for a second and split your screen kind of like I have mine. Okay, so when you're doing, or what we're talking about here is we are looking at the data represents the number of days it takes for different tomato plants to produce tomatoes, okay? We're not even going to use this little thing over here, so you can just kind of mark it out. I couldn't crop it out of the photo. Okay, so we're going to be looking at all of this data that talks about how long it takes a tomato plant to produce tomatoes. So looking at all of these numbers, it's kind of just hard to see what it means. I need it to be organized in some sort of graph for me as a quick way to look at it and go from there, okay? Which a lot of like people use when they're making decisions and solving problems like we talked about in lesson 1, okay? So we're going to take all of this data right here and we're going to use it and put it in our calculator. So if you want to make a little, thing over here of how to make histogram in calculator. Okay, make you a little note off to the side and so we can do our steps. Okay, step 1. Click the stat button, okay? So if you're looking at your calculator and you see the green alpha button, it's 2 over from it. So I'm gonna click on stat and you should be taken to a screen that looks like this, okay? So which brings me to step 2. We're gonna click on this button right here that says edit. So it should be hovered over the 1 and we're gonna click edit. Okay, so I'll just hit enter and it's going to bring me to a screen like this, which I already have data in it from, I guess, something else. So in order to, if you have data in yours, which you shouldn't, but if you ever need to do this, you just click up and highlight the list title, hit clear and enter. Okay, so now your screen probably looks like this. Okay, so you don't have to write those steps down. Now in this list, we're going to type in all of this data. Okay, so take a second real quick and type that in. So I'm going to start with my 47 and then I'm going to hit enter. 52, and it doesn't matter what order you put them in, it's fine. You don't have to put them in from least to greatest. Okay, so take a quick second and do that. Okay, I'm not going to fast forward myself so that you have plenty of time to get it done. Okay, so I've typed mine in. If you're still going, just pause the video, finish, and come back. So according to my thing, if I were to just go up to my last number, it should show me how many are in the data set, which I had 30. So if you have 29 or less, you need to go back and see where you may have made a mistake. Okay, so step 3, we typed in our data. All right, step 4. Okay, so we want to take this and we want to make it into a histogram. So what you're going to do is, if you notice right here above the y equals on your calculator, it says stat plot in blue. We want to get to that. So in order to access that blue, we have to hit the blue button, which is second, and then click y equals. So you should be taken to this screen. Okay? Make sure you hit second y equals in order to get to this screen. If your screen looks like this, whoops, if your screen looks like this, then you didn't hit the blue button first. Okay, so go back to our notes. We hit second, and then we clicked the y equals button. Oh my gosh, what is wrong with my pen? Y equals. Okay, coming back here, we're just going to click on this first plot that says plot 1. Okay, all of yours should be turned off. So we're going to click on 1. Okay, step 5 is number 1, plot 1. Okay, so right here, my little thing is blinking on because it's off right now. So we need to hit enter and turn it on. Okay, so make sure it's on, it's blinking, and it's the black box is on the on. We're going to go down, and we have a bunch of different types of graphs that our calculator can make. We want to scroll over to the histogram. Okay, it's this one right here. So I'm just going to arrow over, and hit enter. All right, on XList, this just tells us the list of where we typed in all of that data to begin with. Did you notice how there was an L1, an L2, L3? We typed ours into L1. Okay, now obviously if we typed it into a different thing, then we would change that, but we didn't. Frequency stays 1, and this, I think this is only on the newer calculators, or if you're on the Chromebook one, you can change the color of your graph if you wanted to. Okay, I'll do red. Okay, so step 6, we turned it on, and we chose graph. Okay, then we got to number 7. All you're going to do is you're going to click zoom, which is right here at the top of your screen. The middle button at the very top. You'll click zoom. And the last step is, remember, step 1, we were doing statistics. Okay, so our last step is going to have something to do with that too. We're going to hit the one that says zoom stat. Okay, so that's number 9. So you can either arrow down or you can just hit the number 9. Okay. I'm going to write that last step over here. Number 9, zoom stat, and it's going to put you a histogram on here. Now, if it says something about it being like an invalid error or something like that, you need to go back to second y equals and make sure all of your other graphs are turned off. And you can just do that by hitting number 4, enter. Okay? And if not, then don't worry too much about it. I'll be back and I can show you. Okay, so this is what my histogram looks like. I need to play around with it. You can move your arrows, and then you can just move around on your graph and see where different amounts are. So like this line that starts at like 54 and goes to 61. So I'm assuming it's counting by roughly 5s. I'm not really sure because I've still got to play around with it a little bit more. But it's going to be less about knowing those specific values. As we move forward, we're really going to be looking at the shape of the distribution, which is how it increases or decreases, which we'll talk more about in lesson 4. Okay, but the main thing is just kind of practicing this over here that we just did, and seeing what our calculator can do with all of this little data. Okay, so that is how you make a histogram. You can also use that, go to second y equals, go back to your plot, and we can make a box plot like we looked at, which is the 5th little thing right here. Enter, zoom, stat. All right, and we can see what it looks like. So we can move around on it and see those values, which I wouldn't use this as much to tell me what the 5-number summary is, as I would something I'm going to talk about in the next little section. Okay, so there's a lot of different things these calculators can do. So we're going to kind of move away from just taking all that time to draw them by hand and seeing how our calculators can do it for us. Okay, so that's it for 2.2. Okay, so we'll go ahead and go on to 2.3, still talking about the tomato plants. So it says a box plot can also be used to represent the distribution of numerical data. So going back to the histogram, I told y'all eventually we're not gonna use this to just see the exact values. We're gonna see how it shows us the shape of the distribution, which we can see that it kind of increases, and then it kind of gets to a peak, and then it starts to decrease. Okay, so histograms are really good at showing that shape of distribution. But also, according to this over here, a box plot can also show that distribution. Okay, so when you're doing a box plot, you need to know the 5-number summary. Okay, so that's something you have to do when you're doing a box plot every single time. Okay, that's what a box plot is the 5-number summary. And the 5-number summary is made up of these 5 things right here. Okay, you have your minimum, you have your Q1, which we'll talk about what that is. We have the median, we have the Q3, and then we have the maximum value. Okay, so once again, we're going to be looking at those tomato plants, all of that data, which lucky, I've already typed all of that into our calculator. Okay, if we go back to stat, enter, okay, all of our data from this is still in there, okay? So that's good. We don't have to type all of it in again. All right, it says, using the same data as the previous activity for tomato plants, find the median, highlight median, and add it to the table. What does the median represent for these data? Okay, so first of all, before we can find the median of the data, what is that? Okay, do y'all remember learning that from previous grades? Okay, well, for those of y'all that don't know what the median is the number in your data that's in the middle spot. Okay, but something that's important to know, which I think is like the most annoying part of finding the median, is if you have a set of data and you are finding the median, the first thing you have to do is you have to put the data in order. Okay, so earlier when I was telling you have to put it in your calculator and you didn't have to put it in order, because the calculator does all that for you. So your calculator can actually find the median for you, which is the number in the middle spot, like we just said, without you having to put the numbers in any sort of order. So I'm going to show you how to do that really quick. Okay, so after you've gone to stat and edit, you're at your list, okay? This particular set of data is already in order, but even if I would have done it in a completely wonky order, it wouldn't matter. Okay, so after we've gone to, let me put these steps, we've gone to stat, then we've gone to edit, and we typed in our data. You're going to click on stat again. So click on stat. And you're going to go up, see these tabs up here that say edit, calc, and tests. You're going to go over to calc. Come down here, so that was step 4. So step 5. And click on calc. And then what we're learning about right now is one variable statistics. So it's number 1, you're just going to hit enter. Okay, and then you're going to hit enter until it goes on the calculate. And then it tells you all of this information, which, oh my gosh, those are weird symbols. What the heck do those mean? Okay, so let's just say enter. Okay. All right, well, don't worry about all of these weird symbols right now. I promise we'll get to those, and they're not scary and they're not confusing. Math just shortens words into little symbols. Okay, we know that, but we'll get to all of these later. I promise they're not scary. You're just going to arrow down. Okay, so earlier I told you the 5-number summary, looking back over here at our notes. The 5-number summary was our minimum, our Q1, our median, our Q3, and our maximum. I want you to look right over here on your calculator. It says minimum, Q1, median, Q3, and our maximum. So our calculator just found all of those things for us without having to do a single bit of math. It's beautiful, isn't it? Okay, so go back to our paper. I'll change my color to break up these little notes that we just said. And it says using the data using the same data as the previous activity, blah, 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 find the median and add it to the table. So what is the median from all of that data? What's the middle number? 71. So we're going to go back and we're going to add 71 up there into our table. Okay. All right. So now we have to answer that next part of the question. I know we hate the explaining and blah, 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 but we've got to do it. We've got to see, okay, we found the median. Who cares? What does that even mean? Okay, so going back to what we're talking about tomato plants. So if the median is 71, what does that mean? Okay, I'm going to type this, and y'all just write it on your paper. I know I'm going to run out of space. Okay, so what does 71 tell us? It tells us if that's the number in the middle spot, then half of the tomato plants grew before the 71 days, and half of the tomatoes, don't have to spell anything, half the tomatoes grew before the 71 days, and half of the tomatoes grew after the 71 days. Let me try to, there. Okay, so that's the explanation for that one. So just take a second, pause the video if you need to, and write that down. Okay, because it's one thing to use our calculator to find all these things really quick, but if we don't know what 71 is telling us, then who cares, okay? But it's not even that complicated. If 71 is half right there smack dab in the middle, then half the tomato plants grew before then and half of them grew after, okay? Next, it says find the median of the least 15 values to split into the first and second quarters. This value is called the first quartile, and it's under Q1. Okay, so our calculator finds that value for us. Okay, so basically if we said, let me find it. Okay, so earlier we split the data in half. Okay, and because there were 30 halfway of 30 was 70 and 71, so our middle number, or 70 and 72 right there, so our middle number was actually the average of those two. Okay, when we're finding the Q1, you're finding half of this lower section. Okay, so since there's 30, or I'm sorry, there's 15, it's going to be this value right here. Okay, because 62 is right there in the middle. We were to take our pens and our pencils or whatever, and sorry, go halfway. And then we did that the whole way, then 62 would be our middle number. Okay, but we don't have to make it super complicated like that, because if we look over here in our calculator, it says our Q1 is 62, okay? So it wants us to add that to the table, okay? So our Q1 was 62. All right, but once again, we have to explain what that means, okay? So if half was the median, that's 50%, right? Half is 50%. Okay, then all the tomato plants that grew before this day, that's half of half. So what's half of half? 25%. Okay, so if we were going to top that, if we were going to explain it, then 25% of the tomato plants grew before the 62 days, and then 75% of the plants grew after the 62 days. Okay, so the Q1 is just showing the 25th percent of the data. If that makes sense. Okay, if you're confused, don't panic. I'll be back Friday. I can explain it better. Okay, but just know that's what it's talking about. Median is 50%, 50% right smack dab in the middle. Q1 is half of that. Okay, so that would be 25%. Okay, so all of these plants over here, all of those plants, that's 25% of the total. It took them less than 62 days to produce tomatoes. Okay, which is important to know for farmers, because they want to produce plants a lot faster. So they're going to look back at that data and say, okay, how did we get all those tomato plants to grow so quick? All right, next one is find the Q3 and add it to the table, and then explain what it means. Okay, so according to our calculator, we said it was 78. Okay, so it's pretty much the same thing as the Q1, just the other way around. So 75% of the plants grew before the 78 days, and 25% of the plants grew after the 78 days. Okay, going back to our data. Oops, I guess I probably could have left the 50%. All right, there's the 78 days. So all of this before, we can see that's a lot more of the data now. Okay, that's 75% of the data. We got 50 plus 25, that's 75% grew before the 78 days. And then the rest, that's 25% grew after the 78 days. Okay? So now it says use the 500 summary to create a box plot that represents the number of days it takes for these tomato plants to produce tomatoes. Okay, so let's finish it. So then obviously the last thing is the minimum value. Okay, so that's the lowest. That's 47. We can look in the calculator. Yep, 47. And then the highest is 90. Okay. All right, so now we have all of the information we need in order to draw a box plot, okay? Hold on one second, I forgot to copy that into this. Let me pause this video real quick. Okay, here we go. So, whoops, gotta get rid of that. Okay, so now we have the 5 things we need in order to do a box plot. So we just use all of these and we're just gonna graph them on this line. So the first one is 47, so I'm gonna come over here. 47 is about right there. So you're just gonna draw a little vertical line, just kind of like that. Okay, then we're gonna do 62, something like that. 71, 78, and the 90. Okay, so just because our number line gives us all of these extra numbers doesn't mean that this bottom line is our minimum and this top line is our maximum. They just made sure to give us plenty of space to draw our graph. Okay, so when you're doing a box plot, these 3 middle lines, you're going to connect all of them. Okay, that forms the box of the box plot. And then these outside ones, you're just going to connect using these little lines. Okay, so there we have a little box plot. Okay, so each one of these lines represents something else. Here's your minimum value on a box plot. Every single time, this one on the far left is your min. The one on the far right is your maximum. Obviously, this line is in the middle is your median because the median tells you the middle number. This is your Q1, which remember we said that's 25% is less than. All right, and this is 75%. Okay? All right, we'll talk more about it. Don't panic. We just got to learn it at some point, okay? So it's not bad. But again, our calculator can find all of this stuff for you. I promise it'd be a lot more overwhelming if I showed you how to find all of these things. It takes a lot longer. Okay, so moving on to the last thing is the lesson summary. So make sure you have a highlighter out so that we can be looking at that together. I started to write this. I'm going to notice on that. Yeah, because y'all wrote it in your books. Okay, so if you wanted to practice on another set of data, here's one for you. Okay, you can type in all those numbers and see if you can find the 5-number summary and all that kind of stuff. So here we go, we're getting our highlighters. It says the table shows a list of the number of minutes people could intensely focus on a task before needing a break. Okay, so they interviewed 50 people to see how long they could intensely focus. Okay, so you can see it is not organized at all. These numbers are all over the place. So in order to do any of the stuff we just did, the very first thing you would have to do is take all 50 of those numbers and put them in order. Okay, so that's why it's so helpful to have a calculator, because it does all of that for you. Okay, but they've gone ahead and put it in this nice little dot plot for you. Okay, let's label that because we now know that this is called a dot plot. We can see all the exact data. It's great. In a situation like this, it is helpful to represent the data graphically to better notice any patterns or other interesting features in the data. Okay, so that is why we have to graph it, because without this graph, we can't see a pattern in this nonsense of numbers. Okay, but in this graph, we can kind of better see what's going on. So a dot plot can be used to see the shape and distribution of the data. Okay, distribution is highlighted. We're going to get into what that means more as we move forward in this lesson. It says, just by looking on it, there are quite a few people that lost focus at 3, 7, 13, and 19 minutes, and nobody lost focus at 11, 12, or 15 minutes. Dot plots are useful when the data is not too large and shows all the individuals in the data set. That's exactly like what we talked about earlier. In this example, a dot plot can easily show all the data. If the data set is very large, more than 100, for example, or if there are many different values that are not exactly the same, it may be hard to see all the dots on the dot plot. Okay, so next we're going to a histogram. It also shows the shape and distribution of the data. Okay, so this right here is a histogram. So now it's grouping all of that data into intervals. Okay, so this is kind of helpful to see other things that we can see. Most people lost focus between 5 and 10 minutes, or between 15 and 20 minutes, while only 4 of the 50 people got distracted between 20 and 25 minutes. When creating histograms, each interval includes the number at the lower end of the interval, but not the upper end. Okay, so if we're looking at this one right here, it goes from 0 to 5. It doesn't include the 5. So it's really 0 to 4, and 5 starts this next block. So it goes from 5 to 9 and doesn't include 10, and 10 starts this next little block, which it explains there. In a histogram, values that are in an interval are grouped together. Although the individual values get lost with the grouping, a histogram can still show the shape of distribution. Okay, and finally, the last one we talked about is I don't know why I changed back to yellow in the middle, sorry. That's confusing, going to green now. Okay, here's a box plot. Box plots are created using the what? 5-number summary that we talked about. For a set of data, the 5-number summary consists of 5 statistics: the minimum, the first quartile, the median, the third quartile, and the maximum value. These values split the data into 4 sections, okay? So the 4 sections are the 50% separates it into 2, and then the Q1 and the Q3 separates it into the other 2. The median of this data is at 8 minutes. Okay, so the median's this little value right here in the middle, that middle line. That's at 8 minutes, and about 25% of the data falls in the short second quarter of the data between 6 and 8 minutes, which is right here. Okay. Similarly, approximately 1/4 of the data is between 8 and 17 minutes. That's this whole section. Like the histogram, the box plot does not show individual data values, but other features such as quartiles, range, and median are more easily seen. All right, so overall, these are all important because of this last sentence. They provide 3 different ways to look at shape distribution while highlighting different aspects of the data. So just like what we talked about earlier, each one of the graphs is useful for different things. So depending on what information it's asking for is going to determine what kind of graph you're going to use. Okay, that's lesson 2 for you. Hopefully that helped and wasn't too confusing. I miss y'all, wish I was there. See the next video, I guess. I don't know how much time y'all have in class. So, bye guys.